In this video, we're going to look at properties of tangent functions and also learn how to graph a basic tangent function. Okay, now if you remember, your tangent function was tan of x, or tan of theta is sine x over cosine x. Okay, so what is my domain? So what is the domain of this function going to be? So let's look at the domain. Recall that my denominator cannot be 0, right? So whatever points cosine becomes 0 cannot be in my domain. I need to throw those points out. When does cosine become 0? And if you remember, cosine becomes 0 at the points when x equals an odd multiple of pi over 2, or we could write that as pi over 2 plus n pi, or we could write that as 2n plus 1 times pi over 2, right? Either one's fine. So domain really is going to be all real numbers except pi over 2 plus n pi, where n is an integer. Okay. Also, let's look at the range. Well, sine and cosine both have a range of, they have a limiting range, right? So it goes from -1 to +1, right? I cannot go more than -1, I cannot go less than, I cannot go more than +1, and I cannot go less than -1. But now think about this, is when cosine becomes really, really small, right, what happens? My denominator is really becoming large, my denominator is super small, which means the smaller the denominator, the bigger the fraction, right? And so technically there is really no stopping this function from becoming as big as it wants. And so my range in this case, and we'll see that in the graph, but the range in this case is going to be all real numbers or -infinity to infinity. Okay, now here's one thing how tan is also different from sine and cosine. If you remember, sine and cosine had no asymptotes, but tangent is going to have asymptotes. Okay, recall from chapter 2 when we graphed rational functions that wherever my denominator becomes 0, right? If this is in the simplest form, if my denominator becomes 0, then that's where I get vertical asymptotes. So all these points where cosine becomes 0, right? First of all, they're not in the domain. Second of all, those are the points where I'm going to have vertical asymptotes. So in this case, I get vertical asymptotes at the points, or x equal to pi over 2 plus n pi. Again, n is an integer. Okay. Then what are the zeros of my tangent function? Well, it's a fraction. I have sine or cosine. When is a fraction equal to 0? A fraction is equal to 0 when my numerator becomes 0, right? So basically, wherever sine is 0, tangent has to be 0. And so that we know it happens at n pi. So zeros of my tan function are n pi, where n is an integer. Okay. The period of a tan function is pi. It's half of what is the period of sine and cosine. And here's one explanation for it. If you remember, say this is my unit circle. Okay. And so this is where all my functions are positive. This is where sine is positive, tangent is positive, and cosine is positive. So basically, tangent is positive here. So it takes all the positive values here, from here to here, and then it takes all the possible negative values, right? So tangent has already covered all its values from here onto here, going from 0 all the way to almost towards infinity, right? I get an asymptote here, and then I'm going to go back to 0. Okay, and so what happens here is, in the third quadrant, again, tangent is positive, right? So all these values that were covered by tangent in the first quadrant are covered in the third quadrant. And all the negative points that are covered by tangent here are now covered over here. So these values repeat as we go down here. So from 0 to pi, when I go from pi to 2 pi, all these values repeat again, okay? And so the period of that function is pi. And then finally, tangent is an odd function. And why is that? Because think about this. tangent of negative x is going to be sine of negative x over cosine of negative x, okay, which is negative sine x over cosine x, right? Because cosine is positive, so cosine of negative x is just cosine x, and this is nothing but negative tangent x, right? So tangent is an odd function, which means it is symmetric about the origin, right? So of about 3 functions that we have studied, sine and tan are odd functions, that is, they're symmetric about the origin, and cosine is the only function we've studied so far in terms of trig functions, which is an even function. So now what I've done here is I've written down the standard angles, right, our basic angles for theta or for x, and then I've computed the tangent values there. Notice that if you remember at pi over 2, the function is undefined because that's where I have a vertical asymptote for my tangent function. Okay, now we're going to go ahead and do this, get our graph, and then we're going to go ahead and look at it on Desmos, right, get a more accurate picture. So let's say this is my y-axis, and say this here is my x-axis. Okay, so here's my point 0. Let's see, this is say pi over 6, pi over 4, pi over 3, pi over 2. So at pi over 2, my function is undefined, and if you remember, tangent is nothing again but sine over cosine, so that's where cosine has a 0, so I get a vertical tangent line. At 0, I have 0. At pi over 6, it's 0.6, so let's say 0.6 is somewhere over here. Okay, this is 0.6. At pi over 4, it is 1, so that'd be somewhere around here, so that's about 1. And then it's 1.7, so let's say that's somewhere around there, that'd be 1.7. And then as I keep going, right, if I join these points, that's how my tan function is going to go. And then my other, if I go on the other side, so that's roughly negative pi over 2, I'm going to have another vertical tangent line. Okay, and so then this function, it's symmetric. Remember, it's symmetric about the origin, so once I have this half, I can immediately draw the other half. And so that is one cycle, right? It's from negative pi to pi over 2, which is a length of pi, right? This length here is pi, and that gives me one cycle of my tan function. And then if I want to get my others, I can just go ahead and repeat that. Okay, so let's go ahead and take a look at this on Desmos. So here's that same table that I drew on the board. I just added a couple more points here of 7 pi over 18, 4 pi over 9, and then 17 pi over 36. So if I go ahead and graph these points, right, it goes something like that. All right, now let's go ahead and graph our tangent function. And there's my tangent function, right? So if you look at it carefully, this doesn't show us the asymptote, but you can see that as I approach pi over 2, right, this is going towards infinity. As I approach negative pi over 2, that's going to go to negative infinity. Okay, so this is the graph of my tangent function.